care about here? The one on the bottom, the x. If your term has an x or a constant, you do your derivative completely normally. If it does not, you have to add in that extra stuff, right? The dy dx, or what we're going to see is something else here. So if we go through one term at a time here, I can do this one normally, yes? What is the derivative of x squared? 2x. We've already done the derivative of y squared. We already know that's not normal, but how do we handle it? 2y dy dx. All right, so someone make a prediction. T squared does not have an x.
2t dy dt.
Not almost.
Almost 2t, right?
dt dx. The bottom stays the same. So I go through the t squared and I say the derivative of 2t, or t squared is 2t. Then you multiply by the derivative of t, which is dt dx. And you're still solving for the dy dx, whichever one they tell you. What's the derivative of 10? 0. That's the only difference when there's more variables. The top always matches the variable you're taking the derivative of. The bottom stays the same, dx. Okay, so if I go through this and I solve, which one am I solving for? The dy dx. So anything that does not have a dy dx moves to the other side. So I would leave the 2y dy dx. I'm going to say all the d wrongs, right? Then move the 2x to the other side. Move the 2t dt dx. And then it's all going to be over what? 2y. The only thing I would reduce is they all have 2's. So I would reduce them all by 2. All right.
I think without us going over the homeworks, I don't think that would.
Yeah. When I am looking at example 2, what is the difference between the original review question we did and now example 2?
You got dt on bottom.
Now I have dt on bottom.
So we just
All right,
solve.
so,
We just would solve.
nope. So the question is going to be,
Holy crap.
does my variable match that?
No.
Okay, none of the variables match that, which means they're all special, right? All right, so let's go through this.
So we can't solve it.
Nope, just
Yeah, you factor it out.
hang on a minute. Hang on a minute. For the first time, just listen. For the first time, does my x term match the variable on the bottom?
No.
No, so how do we take the derivative when the variable does not match?
2x times.
I do 2x times, what's the derivative of x now? dx dt.
Okay, now I see.
All right?
I told.
So once we have that, we do the next one. Does y match the variable on the bottom? No. So I take the derivative of y, which is what? 2y dy dt. 10 does not have a variable, so what is my derivative? 0. No, we can still get dy dt by itself. That's all we have to do. Okay? So if I would like to get dy dt by itself, what do I need to move?
Minus the x thing.
Minus the stuff with the x to the other side.
Oh.
You might have a d something in your answer, and that's okay. Now, what do you still have to get rid of to get dy dt by itself? Divide by 2y. So dy dt equals negative 2x dx dt over 2y. What is the only thing I can simplify? The 2's. All right, before we do any other letters, it actually, Like, once you get the basics last class, which is a little confusing, once we start doing this, the d something makes a little bit more sense. Because then you know when to use it and when not to.
It's like, I'm with you.
Okay.
I got you.
All right. Now, this, I don't have a whole lot more examples to go through, actually. We're going to stick with this next equation for the next few. All right? So, using this, all right, so here we are just throwing random variables in here. Like, I'll be honest, I just threw random variables. That's fine, okay? We would like to solve for that. dx dm. All right, so stick with me here. The large question for every term is, does it match the variable on the bottom? So the variable we care about in this one for the first one is m.
Yep.
All right, so I'm going through one term at a time.
2x dx dm.
X does not match, so it is 2x dx d what? M. Plus, next term, does a match?
Yeah,
No. So how do I take the derivative of a?
3a squared dA dm.
Okay, dA dm. Third term, does the m match?
Yes.
Yes, so the derivative of that is just
Negative 2.
-2. Last one on the other side, does the p match? No.
No.
So how do I take the derivative of this?
2p to the 3.
2p to the third. What do I have to add in?
dp dA.
Okay, good. Are we all okay through that?
We're okay.
What are we solving for?
dx dm.
dx dm, the first one.
Just move everything else over.
So move the other things over.
And then divide it.
The first thing that I would move is the 2 and that at the same time. So that gives me 2x dx dm equals 2p cubed dp dm minus 3a squared dA dm plus 2. What's the only thing we have to get rid of? Divide by 2x, which would be my final answer.
We can't cancel, right?
You can't because of that 3 in front of the a. Yes. Okay. All right. So using the same formula. Keep the same formula, solve for what this time? dA dm. So do you have to redo the derivative? Do we have to redo it?
Take down what you did.
You can take this and solve for which one?
dA dm.
All right, so take a minute, take that blue statement there, and solve for dA dm. Yes, it's algebra, but same derivative. So for this one, dm dp, go back to the beginning, and now the question is, does your variable match what? dp. Yes. So that is the big one that we care about on this one. See if you can do that one from the beginning. So after my first step there, I want to solve for that. Because I want to solve for that, I move everything to the other side and divide by -2. So that would look like this. Oops. Jake, you're whining.
Like ours hurt. Like ours hurt. Yeah, because they're like so class hurts.
I don't know if I can do my test corrections after this. Let's have to do this next week.
All right. Check that one. I know. All right, let's finish up because I know we're ready to be done. Any questions on that?
No, ma'am.
All right. Last but not least, the 3 on the next page, or yeah, 3. Some of these we're going to get actual number answers for. So this is like headed towards what we're going to do with this the next 2 classes. Where do we recognize this from? It's area of a circle, right? So this is just a basic formula that we've been familiar with. We're going to treat this the same way we've been treating the other ones. We would like to find dA dt. Okay, so my question for every variable is, does it match? No. So if I go through this, how do I take the derivative of a? 1 what? dA dt. Yep.
No, you found it.
You do not.
Stop there.
It's already solved for, which is nice. I do have to take the derivative of the right. How do I take the derivative of the right?
How do you take the derivative of pi?
What should we call
Pi is just a number,
It's just 3.1.
so it's just like there's a 2 in front.
So it would be
2 pi r.
Wait, what? Why do you need pi?
Okay, so
What is the point?
let's just say this. Let's just say that was 6r squared. What would you do?
Multiply.
Take the 2 down, multiply it by the 6, right? Well, that pi is just a number. So you bring... Okay, there's too many people talking. No one is going to
I
understand.
don't know where the 6 is.
I know. I said, let us say that we have 6r squared. If you had to find the derivative of that, what would you do? Take the 2 down, multiply it by the 6 to give me 12, reduce it by 1, right? So let's treat that the same way that we're treating this.
So 2
No, pi is a number.
2 pi r, right?
That's like the 6. So it's just 2 pi r. You bring the 2 down, multiply it by pi, keep the r, and reduce by 1. Jackson, what is your question?
So I don't why can't we just find the ADT and you have that? So why?
You still have to do the derivative of the right-hand side. You can't just do something to the left and not do it to the right. If I am now taking the derivative of something with r in it, what do I have to add in? dr dt. Now, do I actually have to solve anything? No. Because dA dt is already by itself. You just take the derivative of the left, derivative of the right, making sure what matches with the t. Okay?
You put the 6 down, and I thought we were multiplying
Yes,
2
no.
times 3.14.
No, no.
I think
All right. Now, here's where we're going with this. Given this fact and this, solve for this. What can we do when we are given numbers? Plug them in. It's not hard, right? So where do I put the 1.2? dA dt is equal to 1.2. So take this out. We're using our formula. Keep the 2 pi. What can I put in place of the r? 2.
Oh, we're using it.
We're using that.
That's why I was so confused.
I would like to solve for dr dt. So grab a calculator. What do I have to do to solve for dr dt? Divide. Now, if I'm going to divide by 2 pi and 2, I got to put parentheses around all of that. So in my calculator, I am doing 1.2 divided by, in parentheses, 2 times pi times 2.
So are we just gonna do away with the centimeter square we're seeking? Is that not
Yes, that is just the measurement of it. We're going to talk about what that is next class and why we have it. But for right now, we are just getting an answer for dr dt.
Is that not 4 pi? Might be a number.
It is 4 pi, but we're going to get a decimal because we're going to divide it into 1.2.
Copy.
So I'm literally taking 1.2 and dividing it by 4 pi in parentheses. I got out of my calculator 0.095. Okay? We are doing that one more time and I am done. Okay? All right, what formula do we see here in example 5? Where do you remember that one? It's a volume formula.
It's of a parallel.
Close. Cone. Volume of a cone. Anything that has a pi and an r in it is circular somehow. So it's a cone. All right, so if I want to find dv dt. All right, so let's go through one at a time.
Wait, it's the same as the
It's just gonna be dv
Right.
dt.
Because if I take the variable of, or the derivative of v, it would be 1 dv dt. Now I do have to handle the right-hand side carefully, because how many variables do I have?
1, 3, 4, 7.
2. 2 variables.
Oh yeah, 1/3. Yeah, r.
The r cubed is 1. The h is 1.
So is the 1/3 pi?
That's just a number.
So that would just be.
But do you distribute the 3 to
Wait,
the
that would just
pi?
become pi r because if you.
We're going to talk about that. So what you have to do here, guys, to finish this one up, you might have to listen. Remember when we did the product rule on our homework, we said we had to like pick what's the first term and what's the second term? If it was me on this one, I would say all of that is the first part. Okay, why can I make all of that the first part? Because 1/3 and pi are just numbers. So I'm going to keep all of that with the r cubed, and my second term is going to be the h. Because I have 2 terms multiplied together, what rule do I have to use here?
Product.
Product. Okay, so let's go through product rule. How does product rule start? Derivative of the first. Remembering that 1/3 and pi are just numbers. How do I take the derivative of 1/3 pi r cubed? Bring the 3 to the front. When I multiply that by 1/3, what does that give me? 1. So 1 pi, keep the r, and do what to the exponent?
Subtract 1.
Subtract 1. In the product rule, what comes after the derivative of the first? Times the second. And real quick, what did I forget on the derivative of the first? Because I just did that.
The times dh.
dr dt, because it does not match. Times the second, plus the first term, times the derivative of the second. What is the derivative of h? dh dt. No, we don't have to do anything in solving for this
It's already set to.
because it's already solved for dv dt. Now, last thing. Given the following, solve for what? dh dt. Do not solve algebraically for this. And by that I mean plug your numbers in and then solve. So go through one at a time. What can I put in place of dv dt?
Negative 12.3.
Negative 12.3. I have 1 pi. What can I put in place of r? 7 squared. What can I put in place of dr dt?
-0.
Point whatever, right? What can I put in place of h?
24.
24. Plus 1/3 pi. We already said r is 7 cubed, and I'm solving for dh dt. I would never solve that without plugging in the numbers. It will be way too nasty. This? No.
Do you just divide the whole?
All right, so let's look at this.
Or you subtract. Just add 12.3, right?
All right, so this is all one term. How can I move that one whole term to the other side?
Subtract.
Subtract. So in my calculator, I would do this. Negative 12.3 minus pi times 7 squared times negative 0.025 times 24. All at once. I'm going to get a decimal from that. So when I subtract all of that to the other side, my calculator gives me 80.06. What do we have left on the other side?
1/3 pi, 7 to the 10.
Okay. Now, because that has a fraction in it, I might type that in and get a number from it. So I might say 1/3 times pi times 7 to the 3rd. I get that that's like 359.19. And what do I have to do to solve? Divide. So I do 80.06 divided by 359.19. And I get 0.22-ish. We are headed in a direction with this that we will need to be able to do that, but what I'm trying to do is give you the pieces at the beginning so that you don't have to do it all without just like jumping into it. Okay?